This is paper 41, May June 2021. Still questions. Question number 8. We have discussed the whole paper, and today we are going to start the next question. That is question number 9. It's related to carbon 13 NMR spectrum of a compound A, and also like organic chemistry, ultimately organic synthesis. In this question, they are asking the carbon 13 NMR spectrum of compound A. Compound A is the C8H8O2 contains six peaks. Okay, means six chemical environments in total. In total, it has six chemical environments, right? Compound A reacts with an excess of bromine water. Okay, means that it has a double bond. It has a double bond. So basically, this is going to, these statements are going to give you a proper hint. So ultimately, I can say that. Ultimately, I can say that. I can say that excess of bromine water means that double bond, double bond is present. Compound A reacts with alkaline aqueous iodine. So alkaline aqueous iodine means it may have 2-degree alcohol, or it may have this compound, this group basically, right? It's indicating. It's indicating basically. Next one is compound D reacts with PCl5 to form compound A. Oh, nice. Reacts with PCl5. What do you mean by PCl5? It means that it must have OH group, presence of OH group. That's why it's gonna react with PCl5. Compound E reacts with propane 2-ol to form compound F. This is the next hint for you. Propane 2-ol, it's going to react with propane 2-ol. You know what does it mean? Okay, it's a carboxylic acid. That's why it's going to react with propane 2-ol. That is your alcohol. That's your alcohol, right? So it's a good hint for you. So in this way, I can think that the compound A would be, you have to make 8 carbon atoms. You have to draw 8 carbon atoms basically, okay? And so your compound A must have double bond. Your compound must have uh, this group, 2-degree alcohol, and your compound must have OH group, and your compound must have carboxylic acid. It has 2 oxygen atoms. It has 2 oxygen atoms basically. In total, it has 8 carbon atoms, and also it has 8 hydrogen atoms. So we have to complete this. We have to complete this. So the thing is that it must have 6 peaks in total. It must have 6 peaks in total, remember, okay? Or I can say that draw the structures of compound A, B, C, and D, E, and F. So if it has 8 carbon atoms, so I'm thinking that it may be alkane, it may be alkene. But the thing is that if it could be alkane, so it must have like the double hydrogens as compared to the carbon. But it has only 8. Only 8. Like the number of carbons are equal to number of hydrogens. So I can think that it's highly unsaturated. So it's gonna, you can say, indicating that this is going to have a ring. This compound must contain ring. In a ring, we have the least number of hydrogen atoms. This is a good hint for you. So ultimately, I'm going to draw the ring. I'm going to draw the ring. So this is the ring for you. So in the ring, you have 6 carbon atoms, right? In the ring, you have 6 carbon atoms, since the ring is highly unsaturated, like it has a double covalent bond. Or now, how many carbon atoms are left? So 8 minus 6 is 2. 8 minus 6 is 2. So two carbon atoms are left. And I know that it has OH group. And I know that it has OH group. Remember, why? Because it's going to react with PCl5. You know, it's going to react with PCl5, remember. So, but it's for compound A, it's for compound A, it's for compound D, it's for compound E. So we have to take care it, so your A must have the double bond, which is this, and your A must have this group, this group, right? So I can just imagine that this is going to be just like that. It's gonna react with alkaline aqueous iodine. That's the reason I got an idea that this group must be present. Okay, this group must be present. So what was the formula? Let me tell you this. Hydrogen 1, then 2, then 3, 4, 5, 6, 7, 8. 8 hydrogen atoms. Am I right? 8, 3, 4, 5, 6, 7, 8. So it has 8 hydrogen atoms, right? Okay. So, but oxygen is less number of less number of oxygens. So I need one more oxygen. I need one more oxygen. That would be OH over there. That would be OH over there. Okay? Okay? So this is your compound A basically. So let me tell you the total number of hydrogen atoms. One, two, three, four, five, six, seven, eight. 8 hydrogen atoms, okay? 2 oxygen atoms and 8 carbon atoms. That's it, okay? And then I'm thinking about B. I'm thinking about B. So it's going to be it's going to have the bromination reaction. Obviously, the bromine would be added on the double bonds ultimately. So the question is that where the bromine would be attaching. This is the main question. You can see that OH is your electron donating group. Think about this. This is very important concept. It's electron donating group and it's electron withdrawing group. So this is gonna shift 1, 2, 3, 4, 5, 6, 2 and 6 positions. So the bromine could be attached here and here. And according to this, it's a 3 and 5 director. So 1, 2, 3, 4, 5. So ultimately, I'm supposed to draw the same compound. I'm supposed to draw the same compound, but I have to add bromine. I have to add bromine. So I would be adding bromine here, as you know that the OH is electron donating group and the CH3 C double on O is the electron withdrawing group. So it is decided that the bromine is going to attach on the 2 and 6 positions as compared to OH, like according to OH, and it should be attached on 3 and 5 positions, as compared to like CH3 C double bond O. So this is your B. Two bromine atoms are attached. Now they're asking about C, yellow PPT. Remember, always it would be CHI3. It would be CHI3. It's the formula for iodoform. It's the formula for iodoform. It's the formula for iodoform, which is white PPT. Sorry, which is yellow PPT. Okay. And then regarding the iodoform test, iodoform reaction, what is supposed to be another species? If you remember the iodoform reaction, so we used to discuss that along with your you can say iodoform, that is CHI3. The salt is also produced ultimately. So I would say that I would say that I'm going to copy this so that I can let you understand how this reaction is gonna happen basically. So CHI3 is removed. CHI3 is removed. I can say that CH3 is removed, and this is going to be formed. This is going to be formed. That's it. It's your D. It's your D. And then I'm going to do uh you know uh it's gonna react with PCl5. The thing is that PCl5 is going to replace this OH or this OH. So remember, this OH is very strongly bonded with the ring because this is electron donating group. It's gonna make the double covalent bond with this ring. So ultimately, you cannot break it down easily. So PCl5 is the reagent for the carboxylic acid. So the OH, which is connected to the C double bond O group, is going to be replaced by the Cl. So I can say that the formula would remain the same, but with the Cl, not OH. Okay. Then it's going to react with propane 2-ol. So propane 2-ol would react with this acyl chloride, and it would be forming, it would be forming ester. It would be forming ester. So propane 2-ol is this. If this OH and this Cl would be reacting together, this H and this Cl would be reacting together. So I can say that I'm going to draw the same compound again. So this Cl and that OH, like H, is going to react with this, and it would be forming this. It would be forming this. So it's very easy to identify whenever your whenever your acyl chloride is going to react with you can say propane 2-ol, that is alcohol. So this is your F. You can justify your structure by looking at the conditions that what they gave you basically. So that's all about the paper. Okay, this was May June paper 41 2021. So now you can have an idea, okay, how you would be doing this paper. Okay, so